guys, welcome to i5 Math. In today's video, we want to talk about least common multiples, or LCM for short. We will show you two different ways of calculating an LCM. The first one uses multiples and the second one uses prime factorization. Using the multiples method comes in handy when we work with smaller numbers. However, when the numbers are large, it would be best to use the prime factorization method. So let's get started. Before we do that, however, we need to know what a multiple is. A multiple of a number is simply the product of multiplying this number by an integer. As you probably already know, integers are whole numbers without fraction components. There are both positive and negative integers. However, for now, we will only work with the positive ones, and we'll leave the negative numbers for another video. If we take the number 3 and multiply it by the integers 1, 2, 3, 4, and 5, we get 3, 6, 9, 12, and 15. All of these numbers are in fact multiples of 3. Sometimes a multiple of one number can also be a multiple of another. 16 is a multiple of 4 because 4 multiplied by 4 equals 16. On the other hand, 8 multiplied by 2 also equals 16. Therefore, we can say that 16 is a common multiple of 4 and 8. Now, let's calculate and compare. Let's list the first 5 multiples of 3 and 6. When we complete the multiplication, we uncover two common multiples, the numbers 6 and 12. Of the two, 6 is the smaller number, and in fact is the smallest or least common multiple of both 3 and 6. Here is another easy example. What is the LCM of 2 and 5? Let's list the first 5 multiples of both 2 and 5. As we can see, 10 is the LCM of 2 and 5. Now, how about picking the numbers 18 and 56? Since these two numbers are larger, calculating and writing down their multiples until we spot the common one might take too long. Instead, we can use the prime factorization method to break down each number into its prime factors. Then, we would be able to uncover their LCM. If you are not familiar with prime factorization, check out our video on the topic. We will leave a link in the video's description below. So, here we go. Finding the LCM of 18 and 56 using prime factorization. 18 divided by 2 equals 9. 2 is a prime number, but 9 is a composite one. 9 doesn't divide by 2, but it divides by 3. 9 divided by 3 equals 3. We got the prime number 3 2 times. So, the prime factorization of 18 is 18 equals 2 times 3 times 3. Next, we break the number 56. 56 divided by 2 equals 28. 28 divided by 2 equals 14. 14 is not a prime number, so we keep dividing. 14 divided by 2 equals 7. 7 can only divide by 1 and itself. Therefore, it is a prime number. So, the prime factorization of 56 is 56 equals 2 times 2 times 2 times 7. Our next step, let's list every kind of prime factor which we came up with during the prime factorization of both 18 and 56. There were 3 kinds of factors, the number 2, 3, and 7. Now, in order to find the LCM of 18 and 56, we will compare the 2 factorizations and will take each factor at its maximum number of repetitions. 2 is present once in the factorization of 18, but is present 3 times in 56. Therefore, we take 2 times 2 times 2. 3 is present 2 times in the factorization of 18, but is not the factor of 56. Therefore, we can take 3 times 3. Finally, 7 is a factor of only 56, and it is present only once, so we take it as it is. Finally, we multiply all of these factors together to get the LCM of 18 and 56. 2 times 2 times 2 times 3 times 3 times 7 equals 504. Let's do one more example, including 3 numbers this time. What is the LCM of 9, 16, and 20? First, let's take 9 and break it into its prime factors. 9 is not divisible by 2. We try the next bigger prime number, 3. 9 divided by 3 equals 3. Great! The prime factorization of 9 is 9 equals 3 times 3. Next, we break 16 into its prime factors. 16 divided by 2 equals 8. 8 divided by 2 equals 4. 4 divided by 2 equals 2. Voila! The prime factorization of 16 is 16 equals 2 times 2 times 2 times 2. The last number we break is 20. 20 divided by 2 equals 10. 10 divided by 2 equals 5. Since 5 is a prime number itself, we don't have to keep dividing. The prime factorization of 20 is complete. 20 equals 2 times 2 times 5. Now, in order to find the LCM of 9, 16, and 20, we will compare the 3 factorizations and will take each factor at its maximum number of repetitions. 2 was not a factor of 9. It came 4 times in the factorization of 16 and was present only twice in the factorization of 20. Therefore, we will use 2 times 2 times 2 times 2. 3 was only present in the factorization of 9, so we will use 3 times 3. And finally, 5 only showed up once in the factorization of 20, so we will use it as it is. Now, we will multiply these prime factors together and come up with the LCM. 2 times 2 times 2 times 2 times 3 times 3 times 5 equals 720. The LCM of 9, 16, and 20 is 720. So there you have it, the prime factorization method for finding the LCM of 2 or more numbers. Thank you so much for watching, guys. If you found value in this video, please click the like and share buttons. Also consider subscribing to our channel. We would greatly appreciate it. Till next time!